2.6 Combination of functions, composite functions preparation. Polynomial in X. A polynomial in X is a term or the sum of a finite number of terms of the form ax to the nth power for any real number a and any whole number n. Okay, so this whole number part, that's the important thing to consider for whether or not this is a polynomial or not. So, whole numbers. Whole numbers are 0, 0, 1, 2, 3, so on, so, right? So they don't include fractions or negatives. Okay, so we're looking at the exponents here. So we have an 8, 6, 4, 2, and this is actually understood to be kind of a 0 exponent if you want to think of it that way, so constants are also included. So we would say this first one is in fact a polynomial, right? So that's a polynomial. Okay, what about the next one? Well, we have a 3, we have a 2, and this one is in the denominator. Okay, so this one is not a polynomial. And another way of writing this would be 4 to the x to the negative first power. We'll get into this later on when we get to radicals. But it's not a whole number. It's actually a negative exponent. So this one is not a polynomial. So let's look at the next one. We have a 3, we have a 2, and we have a negative exponent. Same kind of thing. It's just two ways of writing the same problem, right? 2x cubed minus x squared plus, in one case it was 4 over x. And the other case, it was 4x to the negative first power. Just two ways of writing the same thing. So these are both not a polynomial. Okay, let's dive in and do some examples. Decide whether each relation defines y as a function of x. Give the domain. So we want to decide whether each relation defines y as a function of x. So functions are a specific type of relationship. Okay, so we're decide whether each relation defines y as a function of x. So that's the first thing. And then we want to do the domain. Domains are all the possible values of x that will work in this. Okay, so we have a couple limitations. I do list them out under this example right here where it says if y is equal to 1 over x, then we know that x cannot be 0 because that would make it undefined. So if I was to write this, I would say negative infinity. Whoops. So it'll be negative infinity to 0. And I'll show you how to do the algebra in a little bit. To 0, not including 0, union 0 to positive infinity. Okay. Now also another one is if you have an even root, such as square root of x, we know that x it can be equal to 0, because you can take the square root of 0, which is 0, and it can be infinity. But it cannot be negative, right? Because if you try to take a square root of a negative, you get an imaginary number. So that's a limitation in that case as well. Okay. So let's try these. Now, we decide whether or not something is a function or not. Okay, so let me show you what is not a function, and that'll hopefully tell you what is a function. So if y is to some even power, like the second power, the fourth power, the sixth power, so on and so forth, we would say that's not a function. We could also say if we have inequality symbols, less than, greater than, or greater than, equal to, right? So less than or equal to. So these are all different inequality symbols. These also make it not a function. We'll stop at that, and we'll use those as an example. I'll cover something else in a little bit. So first we want to define it whether or not it's a function or not. So since the first one right here, y is equal to x plus 4, it doesn't have any y to some even power, and it doesn't have any inequality symbol, we would say yes, this is a function. Yes, function. Okay, now what about this one? Well, again, we don't see any y's to some even power. We don't see any inequalities, so we would say yes, this is a function. Okay, what about the next one? Y squared is equal to x. So if I was to graph that out, I would see like that for every x value, except for right here at the origin where that's supposed to go through, you would see that it fails because it hits it more than once. So it fails the vertical line test, or you could look at it algebraically. Okay, so for instance, y squared is equal to x. If we say for every x value, there can only be one and only one y value. We would say, well, what happens if x is equal to 1? We would say y squared is equal to x. That means y would have to either be equal to a 1, right? Because 1 squared is equal to 1. 1 is equal to 1. Check. Or you would say y is equal to negative 1, because negative 1 squared is equal to 1. Negative 1 times negative 1 is positive 1, and 1 is equal to 1. Check. So in this case, there's actually two possibilities. So whether you look at it graphically or whether you do it algebraically, you come to the conclusion that for every x, there more than one y that is associated with it, right? So if you plug in an x value, you get two y values instead of just one, except right here at the origin, but it has to pass the entire thing. Okay, so that's kind of how it looks graphically, and that's how it looks algebraically. So this is not a function, not a function. There we go. Okay, so let's look at the next one. The next one is an inequality symbol right here. So this one is also not a function. Not a function. And I will show you why that is. So in this case, let's see, let's do it algebraically first. For this to be a function, for every value of x, there would be one and only one value of y that it spits out, right? So if we say, for instance, well, x is equal to, I don't know, 2. So you'd say y is less than or equal to 2 minus 1, or y is less than or equal to 1. Well, how many y values are less than or equal to 1? Well, way more than 1, right? Well, first of all, there's 1. There's also 0. There's, 0.99. There's 1/2. There's an infinite number of y's that are less than 1. So this fails miserably. This is not a function. So for every x value that we plug in, we get an infinite number of possible y values. Okay, now what would this look like graphically? So let's try this graphically. So graphically, this would look something like this. And because it says y is less than, you would shade all this part down here, right? This would all be solid. Okay, now here's the key on this one. If I try to pass a vertical line test through here, it wouldn't just hit the line, it would hit an infinite number of times all along here, because that's all solid. So it fails it an infinite number of times. It fails the vertical line test an infinite number of times. So there you go. So you can see it either algebraically or graphically. It is not a function. It failed the vertical line test. Okay, now let's try this one right here. It doesn't look like we have any y values, to some even power, and we don't have any inequalities, so we would say this is a function. For every x value, it spits out one and only one y value. So we would say this one is yes function, or just it is a function. Okay, now let's do the domain. Domain is a different question. So these over here are the function questions. Or I put not function. These are not functions. Okay, but what about domains? Well, there's also something you need to memorize called limitations on domain. So there are limitations on domain. And I already went over them above, but I'm just going to do it again. So basically, if you have variables in the denominator, or you have even roots with the variable in the radicand place, then we would say that these have limitations on the domain. Now, looking at the first one, do we have any variables in the denominator? No. Do we have any even radicals with the variable underneath the radical sign, a radicand, right? No. So we would say this doesn't have a limitation on the domain. So the default is, if it does not have a limitation, is that it is negative infinity to infinity. Okay, what about the next one? Okay, well, first of all, does it have any variables in the denominator? No. Does it have any variables underneath an even radical sign? Yes. Okay, well, what we do know is these have to be greater than or equal to 0, right? Because the lowest value that I can have inside that is 0. Square root of 0 is 0, but I can't get negative. Okay, so we know that all this is greater than or equal to 0. Okay, now at this point we would solve it. So plus 1, cancel, cancel. So we have 1 is less than or equal to 2x divided by 2, cancel, cancel. So we know that 1/2 is less than or equal to x, or that x is greater than or equal to 1/2. I could have just easily set the problem up backwards. It probably would have worked out nicer looking, certainly, that way. Okay, and we can even plug that in there, right? So I plug a half in there. 1/2 times 2 is 1. 1 minus 1 is 0. Seems like it checks out, right? So that's how you would write the equation, but you want to write it, generally speaking, you want to write it in interval notation. So since it can be 1/2, we're going to include 1/2, so we use the bracket, and then it can go all the way up to infinity, can work in there. So this is the domain. Domain, like that. All the possible values. And this is over here is also the domain as well. Okay, let's look at another one. Now, just because this is not a function does not mean there's a limitation on the domain. Those are completely different concepts, okay? So, let's look at this. Does it have any variables in the denominator? No. Does it have any variables underneath an even root sign? No. Okay. The default is going to be negative infinity to infinity then. So that is the domain. Let me separate these out a little bit. I realize this is getting kind of complicated looking. There we go. Try the next one. Y is less than or equal to x minus 1. It says it's not a function, which is correct, but does it have a limitation on the domain? Do you see any variables in the denominator? No. Do you see any variables underneath an even radical sign, like square root, fourth root, sixth root, eighth root? No. So there's no limitation on the domain, which means the domain is negative infinity to infinity. Okay, how about over here? This is a function, but that's irrelevant to whether what the domain is. Does it have a limitation on the domain? Are there any variables? Are there any variables in the denominator? Any x's in the denominator? And the answer to that is yes. So this does have a limitation on the domain. So what we have to do is we have to find out what would make this denominator equal to 0, because we know our answer cannot be that, right? So plus 1, cancel, cancel. X is not equal to 1. Now, that's correct, but we want to write it in a form, an interval notation. So we know that it's negative infinity all the way up to 1, but we don't include 1. So we use that parenthesis, not a bracket, and then we start back up. We're starting up at 1, but not including 1, and we go all the way up to positive infinity. And that is the domain.